Welcome back to Math Concepts. We're going to continue our discussion of counting problems. And of course the reason we're doing this is we're looking at probability. And remember, probability is a way to assign a number to how likely an event is. And we make that number by creating a fraction where the numerator is the number of ways our event can happen, and the denominator is the number of ways or the number of things that could possibly happen. Okay, so working with these discrete probabilities involves doing these counting problems so we can see how many ways things can be done. And we've got some tools that can help us. We've got the counting principle, of course, and that just says if we have a task that can be broken up into stages, we do that. We look at the number of ways to complete each stage, and then we multiply. In fact, some people call it the multiplication principle rather than the counting principle. And we also looked at several special tools that can give us shortcuts, like the factorial, permutation, and combination. Okay, your calculator has those as built-in functions to tackle some of these counting problems quicker. So what we're going to look at in this video are some applications that make use of the combination function. Okay, the combination function. Okay, so remember we're trying to use combinations to solve counting problems. Let's take this example first. A restaurant has 16 servers on staff. We want to know how many teams of 7 can be chosen to work the lunch shift. Okay, so it doesn't seem to indicate that anybody is going to be assigned any specific job, like nobody's going to be assigned a host. They're just all working as servers here, so I'm taking it that order doesn't matter. So I got 16 people to choose from. I'm going to pick 7. So combination 16, 7. And I'll use my calculator to help me. Clear it out. 16 people to choose from. I go to the PRB menu. I get the NCR function, 16 NCR 7. And that equals 11,440 possible schedules where you have 7 people of the 16 to work the lunch shift. Okay, so when order doesn't matter, we use the combination tool to help us. Okay, let's go down here. An auditor has 4 corporate tax returns and 6 individual tax returns. In how many ways can she select 3 corporate and 2 individual returns to audit? Okay. So this is the way I would do it. I would break it up into stages. Her first stage is select the corporate tax returns. And then her second stage is select the individual tax returns. Okay, now she has 4 corporate tax returns. She's going to pick 3. Okay, and the order doesn't matter. So combination 4, 3, that's the number of ways to complete the first stage. And then the number of ways to complete the second stage, well, she has 6 individual tax returns. She's supposed to pick 2. Combination 6, 2. And then we'd have to multiply both of those numbers. Okay, because our stages are select the corporate tax returns. That's the first stage, and then select the individual tax returns in the second stage. Okay, so let's go ahead and do the computations here. If I do combination 4, 3, so 4, go to my calculator's PRB menu, do NCR 3, that gives me a 4. And if I do 6 NCR 2, see what that gives me. That gives me a 15. So I got 4 times 15. So that's 60 ways to choose 3 corporate and 2 individual tax returns from the pile that she has. Okay, let's look at one more example. Combinations come up a lot when we're talking about hands in card games because order doesn't matter. Okay, if you have a pair of kings and 3 queens, that's the same thing as having 3 queens and a pair of kings. Okay, so let's answer this question here. How many ways are there to make a 5-card hand with 3 aces and 2 eights? Well, it's actually very similar to the last problem. We're going to break this up into 2 stages. First stage is going to be choose those aces. And then we're going to say choose those eights. Now, there are 4 aces in the deck. Right? You have the ace of hearts, you have the ace of diamonds, you have the ace of spades, and the ace of clubs. So you have 4 things to choose from. You're going to pick 3. That's choosing the aces. That's the first stage. You also have 4 eights. Once again, hearts, spades, diamonds, and clubs. But you're going to pick 2. Okay, so 4 choose 3, 4 choose 2. Take those 2 numbers and multiply them. Okay, 4 choose 3, we computed that last round, that's 4. 4 choose 2, use your calculator, that's 6. So there are 24 different ways to make a poker hand that has 3 aces and 2 eights. And it's a neat little application of using the combinations in conjunction with the counting principle to get this answer.